Hey Elemental, welcome back to another G67 math video. Tonight we're going to be working with compound probability. Let's get started with something just for fun. Where was this picture taken? You should know. We've talked about it in class a couple times. We'll be back with the answer to that trivia question after our instruction tonight. Officially tonight our target is I can find the probability of two events. Let's do this thing. Let's start off with some background. Just a quick review of probability. Here's a gumball machine with 8 red, 7 blue, and 6 green gumballs. Alright? One gumball is picked randomly. What's the probability this blue? Well, total of 21 outcomes. 7 of them are blue, so 7 out of 21. That's the probability. We can reduce that down to 1/3. What's the probability of flipping a coin and getting the heads? Here's another example. Well, total of 2 outcomes. 1 heads or 1 favorable outcome, so it's 1/2. There's your review for this tonight. Here's the actual target. Yeah, but what's the probability of choosing a blue ball and getting the heads on the coin flip? That's not as hard as you think it is. Let's go back. The probability of the blue ball was 1/3. The probability of the heads on the coin was 1/2. Multiply the two together, the probability of both is 1/6. Not too bad, huh? All right, 2 must-know words. First of all, independent events. Independent events are when 2 events that the probability of one event in no way impacts the probability of the other event. The 2 events we just did were independent events. Pulling the gumball had nothing to do with flipping the coin. It didn't impact them all. Spinning the spinner and rolling a die. These are independent events. They don't impact one another. All right? Dependent events. This is just the opposite. That's when the probability of one event does impact the probability or the outcomes, number of outcomes of the other event. The best way to describe all this and put all these together is to look at some examples. So I'm going to do 3 marble examples with you and then have you try 3 examples with cards and see if you can get this down. I think you'll have it by the end of the night. All right, let's get started. First, let's start off with an independent event. So first, we got 2 events here. We're going to pull a marble hoping for a pink, and then we're going to pull again hoping for a red. The important thing to know here is that we are going to put the marbles back in the jar. That's what makes them independent. All right, so our ultimate goal here is to find what the probability is together of pulling a pink and then a red. Well, the probability of pulling a pink is 5 out of 10. There's a total of 10 of them in there. 5 of them are pink. Pretty straightforward. Probability of pulling the red is 3 out of 10 because there's 3 pink or red ones in here out of a total of 10. Together, the probability is then 1/2. I simplified 5/10 times 3/10 gives me 3/20. That's the probability of pulling first a pink and then a red. Are you with me? I hope so. That was the easiest one. Now let's switch to dependent events. This time we're not going to put the marble back, but we're going to do the same experiment. What's the probability of a pink and then pulling the red without putting them back? Okay, well let's think about it. It still hasn't changed. The probability of pulling a pink is still 5 chances out of 10. But the probability of pulling the red is only 3 chances out of 9 because there's 1 less marble in the jar, okay? There's still 3 red ones possibly, but there's only 9 total marbles because we held on to the first marble we pulled out. So we just multiply these guys together. Here's that first event, probability of pulling the pink, probability of pulling a red, multiply them together. We've got a 1 in 6 chance of doing that, okay? These are dependent events. We didn't put the marble back. And again, here's another dependent event. Again, we're not going to be putting the marble back. But this time, we're going to pull, first event is trying to pull a pink, and then the second event is trying to pull a pink too. Watch what happens. All right. Event 1, the probability of pulling a pink, 5/10. It hasn't changed. However, the probability of pulling a second pink, see what happened? Not only did the number of outcomes change, but the number of pink marbles, or the possibility of pulling a pink marble, changed. Each of them went down by 1 because we didn't put the marble back, and we're trying to pull a second pink. So you're going to have 5/10 times 4/9. So the probability of together pulling a pink, then a pink, would be 1/2, 5/10 simplified, times 4/9, the second pink, gives you 4/18 simplified. You have 2/9 is the probability. All right? All right. Before we have you try some, let's just do a quick review of what a deck of cards is. Some kids had a question about this. A deck of cards, first of all, there's 52 cards in a deck of cards. 52 cards total without the jokers. There are 4 suits. We have clubs, spades, hearts, and diamonds. There are 13 cards in each suit, and they're all the same. Each of them have a 5, a 6, a 7, and 8. They all have face cards, jacks, queens, kings, and they all have aces. All right? That's the background you need to understand this next question. All right, it's your chance. All right. I want you to determine the probability of pulling an ace from a deck of cards, put the card back, and then pulling a jack. Okay? Here's the important part. You're going to put the card back, and then determine if these are independent or dependent events. All right? Go ahead and pause the video. I see dead people. Haven't done that for a while. All right, let's see how you did. Get rid of this. They are independent events because we're putting the card back in the deck. So the event 1, pulling the ace, there's 4 chances out of 52. And then we put the card back. And then we're trying to pull a jack. There's 4 chances out of 52. So we can simplify these fractions down into 1/13 times 1/13. We get 1/169th. I bet you got that one. All right, I think that's the easiest one. Here's the next one. Same problem, but we're not putting the card back. Go ahead and see if you can determine if they're independent or dependent, and then what the probability of pulling an ace and then a jack when you don't put the first card back. Go. All right, event 1. 4/52. Event 2, 4/51, because we didn't put the card back and we're trying to pull an ace and then a jack. So because they're different cards, this numerator doesn't change. These are dependent events. Again, it's impacting. This event here is the second event is impacted by you pulling the card and not putting it back. All right, let's take and simplify these. 4/52 is simplified into 1/13. 4/51, I'll just leave that straight up. That's in simplest form. 1 times 4 is 4. 13 times 51. You have a 4 in 663 chance of pulling an ace and then a jack when you don't put the card back. All right. What is the probability of pulling an ace and then another ace? And again, and for this example, you don't put the card back after pulling it. Go ahead and give it a shot. All right. Well, probability of the first event is 4/52. Full deck of cards. However, pulling the second ace, the numerator is going to decrease by 1 and the denominator by 1. The second event, there's only a 3/51 chance. So because these are impacted, it is a dependent event. I can simplify 4/52 down to 1/13. 3/51 is simplified into 1/17. Multiply them together. You got 1 out of 221. That's your probability of pulling an ace and then an ace without putting the card back. All right, time for the ticket to the show. Today, you will be asked to draw 2 marbles without putting the first one back. What is your probability of pulling a red and then a blue from this little jar? Total of 8 marbles. Go ahead and pause the video and answer that question. Okay, here we go. What is the where was this picture taken? Times Square, New York City. This place is alive 24 hours a day. Hope you get a chance to get there sometime before you're 50 years old. That's how old I was when I finally got there. All right, thanks for listening. Hope you understand compound probability. Have a good evening.